All right. We're going to graph sine and cosine. Now we're going to do this on increments of 45, but I'd like to show this in radians. Our highest point is going to be 1. Our lowest point is going to be -1. Mark out a half and a quarter. And we're going to make 8 tick marks. 1, 2. Those are going to represent our 45s. So what is 45 degrees in radians? Anybody have it memorized yet? Okay, then convert it. 45 degrees in radians. How do you convert that?
So it'd be the
45 times what? 5 or 180. It's going to be pi over 4. Okay? If you remember the pattern, 45s go by 1/4. So pi over 4, that's 1/4 pi. This next one will be 2/4 pi, or 1/2 pi, or pi over 2. 3/4 pi. 4/4 pi, or pi. 5/4 pi. 6/4 pi, or 3 pi over 2. 7/4 pi. 8/4 pi, or 2 pi. That would be equivalent to 360. Everybody remember that? And then we go in that negative direction as well. So -1/4 pi, -2/4 pi, or pi over 2. This is 45s. We could do 30s also if we wanted to, but 45 is a good pattern for sine and cosine. So just copying the pattern in the negative direction. And we made a chart the last time we graphed this. You need to have this memorized. I'm going to have you graph the 6 trig functions. You need to know what their points are. Okay? Memorize the chart. You can memorize the graph. I don't care how you memorize it, but you need to be able to draw it from memory. Sine and cosine are pretty much the same way. They just start at different points. That's really what you got to remember. Sine starts at 0. Okay? Does anybody remember the pattern? Start at 0. What's the next value? Yeah, what will be the sine of 45 degrees? I think someone was going to say it. Square root of 2 over 2, which is approximately 0.7.
So you want decimal?
Well, square root of 2 over 2, I haven't seen a measurement that has square roots on it, so I would definitely go decimal. So it's 0.7, just a little bit shy of 3/4, right? Because that 3/4 would be 0.75. Now a half, or I should say pi over 2, 90 degrees. Sine of 90 is what? I hope it's positive 1, right? 1. Now, if you have those 3 points, you can draw the entire sine graph because they all repeat now. You come back down. Next 45 is 0.7. The next 45, which would be 180, is 0. Then it dips down into the negative direction. 5 pi over 4 would be 0.7 negative. And then 270 would be -1. 7 pi over 4, or 315, will be about 0.7 negative, and then back to 0. That's a nice smooth curve, connecting those dots up. It's not a rigid V like absolute value. It is a smooth curve. Okay? Now that would be one period of the sine wave from 0 to 360, or 0 to 2 pi. That's the length of that pattern. And we're going to repeat that again. I want two pattern lengths, or two periods of the function. Okay, so we're going down, obviously, so we're going to be at negative 0.7 for negative 45 degrees, negative 1 for negative 90, negative 0.7 for negative 3, 5, or 4, 0, x 45, positive 0.7, 1, 0.7, 0. And again, we're going to connect that up. This is going to look a heck of a lot better on your graph paper. This is hand drawn up here, so it's a little bit off. That would be two periods of the sine wave. This wave goes on forever in both directions. Just keeps bouncing from 1 to negative 1, 1 to negative 1. Nice smooth boom, back down. Okay, if we wanted to include increments of 30, which would include 60, that's another triangle that we memorized, 30, 60, 90. We could include those points. Okay? But I think you get a really pretty accurate graph with just 45s. If you wanted to be really accurate, you could start throwing in the 30s and the 60s. That would give us a point here. Okay, at about 30 degrees, you're going to have it at a half, which is about right here. That's what 30 degrees would be. And 60, which would be about right in here, would be about 0.86, okay, which is a square root of 3 over, what's the sine of 60? Do you guys remember? Sine of 60. Type it in. Figure it out. Right. So I said, what is that? 0.87 actually. Square root of 3 over 2 is what that is approximately. About 0.87 though here at 60. So here we got 30. Here we got 60. That'd be about that's about 0.9. It's pretty high. So you can see there's more points that we could draw there, right? It would show us more of what that smooth curve looked like. But 45 is really enough to draw the sine. So do you get the pattern? Think you could draw the 45s at least? If we had to toss in the 30s and 60s, would that really be that bad? If you knew that 30 degree, the sine of 30, okay, was equivalent to a half, sine of 60, 0.9 approximately, 0.87. You can put a whole bunch of points on there. All right, let's graph cosine. Everybody have that down? If you didn't have it down before? Again, I'm kind of just going to do 8 points again. Graph paper would be much, much nicer than me just sketching it. Again, we're going to do this on 45s. So I might as well start labeling 1/4 pi, 2/4 pi, or pi over 2, 3/4 pi, 4/4 pi, 5/4 pi, 6/4 pi, 7/4 pi, 8/4 pi, and negatives the same. We'll start out here in the end. So 8, 7, 6, 5, 4, 3, chestnut raised. Here, negative 3 pi over 2 should be negative 3 pi over 4. Now, the only difference between sine and cosine is where it starts. It's the same 30, 60, 90. I'm sorry, same 45. So it's going to be 0.7, 1, and 0. Cosine starts at 1. So cosine of 45 is about 0.7. Cosine of 90, or pi over 2, is 0. 3 pi over 4, negative 0.7. Pi, negative 1. 5 pi over 4, negative 0.7. 3 pi over 2, 0. Cosine 7 pi over 4, back to positive 0.7. And we finish up at 1. And we can continue this on. I can add another 45. That would be what? 9 pi over 4? Like I said, I can just keep going and going. This pattern just keeps going. Then we go in a negative direction. Be about 0.7 positive. 0. 0.7 negative. Negative 1. Negative 0.7. 0. Positive 0.7. Positive 1. Again, if I wanted to, I could add in another 45 out here and just keep it going. Okay? Nice, smooth curve. Nice and smooth. And if I... It's not even close, is it? Try that again. All right, so let's take a look at the graph on our calculator. Okay, we can graph it on our calculator. Cosine of x. Oops. There we go. Now, pi over 4, pi over 2, 3 pi over 4, those are numbers. Okay? If we wanted to, pi over 4. That's a decimal. Pi divided by 2. Now if I can divide pi divided by 2. Buttons don't like it today. Slide this over a little bit. Okay, so as you can see, pi over 2 is about 1.57. We did pi be about 3. So do we have to do anything special to see this graph? If we're in the right mode, no. I'm in radian mode. That means I'm seeing these decimals. It'll recognize pi over 4 and so forth. So I can just say zoom 6, and I should see, okay. Now, am I getting exactly what I want here? If I want to see this exactly from negative 2 pi to positive 2 pi, I have to hit my window. And my x min, I'd have to say, is negative 2 pi. And my x max, I'd have to say, is 2 pi. Now, also, do I only need my y min and max to go as high as negative 10 and 10? My high is 1, my low is negative 1. I'm going to say negative 2, 2. Let me graph. Does that look like what we drew? Now, there's an easier way of doing it. Calculator always makes things easy, right? What zoom do you think is going to make things easier? Exactly. Zoom 7, zoom trig. Automatically puts it to a nice window where you're seeing it from about negative 360 to positive 360. Okay, I think it's close. It's pretty close. I don't know if it's exactly that. So let's take a look at the sine wave. Sine of x. Again, we can go back to our window. We can set the window. Really, the only difference, it's a little off. If I said negative 2 pi, it's 6.283. So you can see that the trig zooms a little off. 2 pi, let's go negative 2 to 2. Does that look like our sine graph? I need to scroll back up. You guys have it on your paper, right? Or if we hit zoom trig, zoom 7, it's just a little bit different. Now, if you want to do this in degrees, because let's say I wanted to check a value here. Let's say I wanted to check, say, 3 pi over 4. Well, I'd have to actually type in 3 pi divided by 4. And I should get about, what, negative 0.7? I'm getting, well, sorry, this is the sine wave, not cosine. So that'd be positive 0.707. All right? If you wanted to do that in degrees, it's simple. Switch modes to degree. Once you do that, you have to use zoom trig if you want to see a normal graph. You have to. Zoom 7, still nice, right? Watch when I go standard zoom. Zoom 6, which is what we were talking about before. That's it. You see anything? Can't see anything at all. Because what's it doing? It's looking for what? 45, 90. This goes 10 by 10. You're not going to see that, right? I'd have to change the window. Okay, so zoom 7 does that. And you can see our window goes from about negative 352 to 352. So you'd have to change it to negative 360 to 360 if you're in degree mode. Any questions on that? So we're okay with the graphs of sine and cosine.